All right, notes are out, please. First page.
Oh, well.
Notes are out, please. First page.
There you go.
We are going to discuss in grade 9. We only talk about metric conversions because we live in Canada and we use the metric system. Next year and in A&W, you will do lots of work with the imperial system that they use in America because we still use that system in construction. So, to talk about the metric system is a much better system because it, of course, is based on 10, just like we count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The metric system is based on that, except it uses French prefixes, which you guys already know. The littlest one, it starts at mm, which stands for milli. Now, in length, it's a millimeter, yes? Now the next one down is a nanometer and then a picometer, but we don't go that low. We stop at millimeter. But the beautiful thing about the metric system is those prefixes work for everything. We also use the metric system for mass, milligram, right? Okay. We also use it yes?
Is that our first break?
No. We also use it for volume. A bottle of pop or a bottle of this bottle of water is 500 milliliters. That's the nice thing about the metric system.
That's like half a liter.
No. Yes, 500 milliliters is half a liter, yes. Because there are 1,000 milliliters in a liter, because milli means 1,000. Okay? So the next one up is centi, which cent. 100 cents in a dollar per cent. Centimeter, 1/100th of a meter. What's the next one?
Meter? No. Meter.
1,000th, 1/100th. So this must be 1/10th, right? What is it? Does anybody know? It's not a measurement we use in Canada very much.
Mile.
Deci. A decimeter is 1/10th of a meter. We don't use it much. They use it a buttload in Europe. And then we get to meter, which is what we call the base in math. Now, obviously, the meter is the base length unit, yes? In mass, it's grams. Milli, centi, deci, liter, or gram, and then we go up to kilograms. Now, it goes higher than that, but we only use these ones. In volume for drinks, it's milliliter, centiliter, deciliter, liter, and then we go up. Okay? Now remember, these are all fractions. Now, in the metric system, it's lovely because the fractions are in tens. So deci is 1/10th, or 0.1. Centi is 1/100th, or 0.01. Milli is 1/1000th, or 0.001. Notice the only thing we do to change the measurements is move the decimal place. That's why metric is good. Everybody with me? Now, obviously, you guys aren't stupid. You know we go above meter. The next thing up from a meter is a decameter, which is not a fraction because it's bigger. We'll come to that in a minute. After deca is hecto, and after hecto is kilo. And this is times 10 instead of 1/10th, times 100 instead of 1/100th, and times 1,000. So if I have 1 meter, that's 1/1000th of a kilometer. Got it? So the same thing happens here. And then below deca is obviously meter. So this part of the staircase would actually go, and I have enough room to do it, there. All right? And all you do is move the decimal point. Okay? So, if I put this here, 77.34 hectometers. You with me? If I go up, I am doing what? Multiplying by? Which is it? What's every step? Times 10, times 10, times 10, yes? Right? Everybody with me? So now think about this. You have to think because it's not natural. Are kilograms bigger or smaller than hectograms? Bigger. So if I multiply by 10, this number is going to get bigger, isn't it? That's not what we want. It's really got to get smaller, doesn't it? So this would be 7.734 kilograms. When you go up, you are dividing because the value is getting bigger. The numbers are getting smaller. Got it? So what happens if I go this way? What would this guy be? What would it be in decagrams? So I move the decimal. When I went this way, I moved the decimal once to the left. So when I go this way, what do I move the decimal? Once to the right, becomes 773.4. Got it? Now let's say you can't remember that. That's fine. I'm going to show you another way to do it right now. Okay? Everybody good? And that's just how it works. So if I move here, the decimal is going to move one more. If I move here, it's going to move one more. What goes in the empty spaces? Zeros. That's metric. Everybody good?
Yep.
That will work with every metric measurement in the universe. Okay? What I'm about to show you will work with metric, but it will also work with imperial measurements. And it will work with unit conversions. So for example, if I go to a store and I see a special on something, 3 bags of rice for $6.99, what I'm about to show you will allow you to work out if you see another store that's selling 8 bags of rice for $14.99, what I'm about to show you will tell you which is the better deal. So it's actually useful in real life, the thing I'm about to show you. Everybody with me? So this works for metric all the time. It works for nothing else. Okay, you can't do this to change between pounds and kilograms or pounds and ounces. You can't do that. But what I'm about to show you will let you do that. Understand?
Yeah.
Okay, so this is one way to do metric conversions, but I'm going to give you another way to do metric conversions right now. You guys should have a little bit of space over here. You make this calculation. You take the measurement, and when I say measurement, I mean anything, the weight, the volume, whatever it is you're measuring. You with me? You take the measurement that you have and you multiply it by a fraction. Okay? And the fraction is always the same thing. The measurement you want, right, over the measurement that you don't want. And I'm going to show you this right now, okay? We're going to use both of these. So we're going to convert each measurement to centimeters. So I'm going to use the steps first. I am starting at 7 meters. So where do I start on the steps? 7 at meters, yes? To go down to centimeters, the decimal needs to move to the right, yes? How many places does it move per step? 1. So this is going to become 70, right? And then it's going to become 700. Everybody cool? I move 2 steps, so I move the decimal 2 spaces. Everybody good? Okay. So 1 meter equals 100 centimeters, so 7 times 100 gets me 700. Everyone good? Now I'm going to show you the other way and show you how it works. What do I start with? The measurement that I have. What measurement do I have here? No. We're going to do this one. What measurement do I have here? 7. And now I multiply by a fraction. What measurement do I want? Centimeters. So I'm multiplying by 100 centimeters over 1 meter. Because that's the measurement that I don't want anymore, right? So what is this really? This is really 7 over 1, yeah? So 7 times 100, 7 times 1, I get 700. Everybody good? Okay. On this one, let's do the steps. 21 millimeters. So where do I start?
Millimeter.
21. I'm going up to centimeters. So where does the decimal go? 1 to the left. So it becomes 2.1. Cool? All right. So now we know that this is going to be 2.1 centimeters. Now let's do the other thing. What did I start with? 21 millimeters, yes? And what did I want? Centimeters, right? 1 centimeter is 10 millimeters, right? So this is really 21 times 1, it's really 21 over 10, correct? And when you do that on your calculator, you get 2.1. Same answer. Is everybody good with that? Now remember, I told you it would be useful to you in real life. You already know why this is useful to you in real life. If I want to make a conversion, there's going to be an unknown somewhere, isn't there? Right? I need to know what 21 is in centimeters, yes? Right? So that's the unknown, isn't it? So what would I put there in math class? X. So what have I really gotten here? Right? I'm back to my fraction situation, aren't I?
Yeah.
Right? And we know how to deal with that. That's how this works in real life. Don't write this down. I'm just going to show you what I mean. You go to Walmart and you see 6.2 kilo bag of dog food for $29.99. Right? Agreed? And then you see they've got an 8 kilo bag of dog food for $35.99. Which is the better deal? You automatically go to the 8 kilo because we're trained to say thinking bigger, right? That's why Costco works. Right? But what should you really do here? You should find out what 1 kilo of dog food would cost, shouldn't you? So if you cross here, $29.99 times that divided by that will get me what 1 kilo costs. So if I go to my calculator, $29.99, multiply the pair, $29.99 times 1 divided by 6.2. So these guys are charging me $4.83 per kilo. Yeah? These guys got to do the same thing. $35.99 divided by 8. These guys are charging me $4.50 a kilo. So in this case, what's the better buy?
8 kilo.
The 8 kilo. Right? But I will warn you, stores like Walmart know that you guys, not you guys because you've been in my class, they know that the general public is stupid. And they know the general public can't do math. So what they do is they price this one to be a worse deal. Okay? What they'll do is they'll sell a smaller bag, like a 5 kilo bag, and if you multiply it, you will find that it's a better deal to buy these. But nobody does that. So you buy the bigger bag thinking buying big is better, and they make more money off you. I told you the story about the energy drinks at Target when it was still open. Yes, I did. You just don't pay attention because it was voice coming out of my mouth.
Like I remember.
Yes. Okay? So, I don't care which way you use. You can use the steps if you want, or you can use the fraction method. All right? Or you can even use the multiply the pair, divide the spare method. Right? This says I want meters, correct?
Correct.
I have centimeters. So I have 346 in centimeters, but I need it in meters. What's on top, centimeters or meters? Centimeters. So I know that 100 centimeters, right, is 1 meter, because I got to keep the same top and bottom. Now if I multiply those, multiply the pair, divide the spare, I get 3.46, right? Now you can do that on the steps, right? Or you can do multiply the pair, divide the spare like I just did, or you can do what I have, 346 times what I want, which is 1 meter over 100 centimeters, what I don't want. 346 over 100 would be 346 divided by 100, or 346 times 0.01. Do you all see the 5 or 6 different ways you can do this? How many ways do you have to be able to do it? Only one to make it work. Whatever works for you. What's this one going to be? You guys do any method you want. Use the stairs, anything you want. What's that going to be? I'm going from millimeters to meters. So you can either count the steps or do math. Who has an answer for me? 1.8. What'd you use, Dylan? Steps? Cool. What about 3? I'm going down the steps. 1 centimeter equals 10 millimeters. Right? 65 millimeters. And here? $3,800. Everybody good? Okay. Aiden. 1 centimeter is 10 millimeters. So 2 centimeters is 2 centimeters.
100 centimeters?
Oh man.
Boy.
1 centimeter is 10 millimeters. So 2 centimeters is
20 millimeters.
20 millimeters.
Oh, yeah.
Okay? It goes up. The distance you are measuring is smaller, but the number you are using has to get bigger to cover that same amount of distance.
So when you got 3.5, what do you times it by 100?
To get to millimeters? No, because it's 1 to 10. There's 10 millimeters in a centimeter. So you've got to multiply by 10.
Oh.
If I was going 2 steps, I would multiply by 10, which would be by 100. So if I was going down to micrometers, it would be 650 micrometers. If I was going down to nanometers, it would be 6,500. If I was going down to picometers, it would be 65,000.
You're always timing by 10.
Yes. That's why metric is the best.
Yeah, what's the lowest?
I don't know lower than pico.
Oh, really?
How do they measure atoms?
Huh?
How do they measure atoms?
They don't. No.
Can you see, like, it?
No. With an electron microscope, you can sometimes see a slightly darker mass that is the nucleus of the really big atoms. Okay? All right. Everybody good with conversions? Just moving the decimal place. However way you want to do it. Is everybody good? Okay. Now, we move on to an actual real-life use of this. Enlargements and reductions. Now, I've already gave this example. Did they build this building somewhere, then take it apart, and bring it here and build it again? Of course not. What did they do?
They built it right here.
Wrong. They drew it out on paper first. Was that paper the size of this school?
No.
No, of course not. It was a small piece of paper. They then used that diagram to build this building, correct? So this building is an enlargement of that diagram. Is that cool? Everybody with me? Yep. All right. So technically, what was the original thing for this building? The diagram or the building?
Diagram.
The diagram. So this is really a model of that drawing. Does everybody follow me? Okay. So now we got to make sure we define that. An enlargement, and we are speaking from strictly a math point of view. An enlargement is a model that is bigger than the actual object. Now somebody here will say, well, but Mr. Myers, that drawing is technically a model of the school, isn't it? No, because when they did that drawing, this school didn't exist. Do you understand? So even though this is an actual thing, it's technically an enlarged model of that blueprint. Got it? Okay, everybody got it? All right. Now from a mathematical perspective, this is what it means. Every measurement on the original is multiplied by a number greater than 1. Do you understand what that means?
Yeah.
If I multiplied it by 1, how big would the thing be? Crickets. Okay. We'll have some fun with this. I am awesome. I'm gorgeous, I'm funny, and I'm brilliant.
Sounds like me.
Everybody with me?
Okay.
Right now, people don't realize how awesome I am. But in 100 years, people are going to be like, man, you know who was awesome? That Myers guy. And they're going to build a statue of me in front of the Abbey Senior Building. Okay? That statue is going to be bigger than me. Well, it would be lame if it wasn't. It's not going to be life-size. Now, you guys all know this. I am 5 foot 8 inches tall. The statue is going to be 20 feet tall. What was the original thing? Me. Is the statue bigger than me?
Yeah.
Yes. Since it is 20 feet tall, my height of 5 foot 8 inches would multiply by a certain number to get a statue that was 20 feet tall. Understand? Not 20 inches, 20 feet. Everybody understand? This number right here. If I multiplied by 1, how tall would the statue be? Same size. Wouldn't be an enlargement, would it? If I multiplied by less than 1, how big would the statue be? Smaller than me. Lame. So then multiply by a number bigger than 1 to get a statue bigger than me. Got it? Now, when you guys come to visit that statue, or your great-great-grandchildren come to visit that statue, and they say, man, my great-great-great-grandpa told my great-great-grandpa, who told my great-great-grandpa, who told my great-grandpa, who told my grandpa, who told my dad, that he was actually in a class with Matt Myers. And your great-great-great-grandchildren who are visiting that will want a souvenir. Of course. So of course we're going to sell stuff. Can I sell a 20-foot statue?
No.
No, I sell a keychain. that is only
Or miniature stuff.
2-inch, a miniature statue that is only 6 inches tall. Is that taller or smaller than me?
Smaller.
Smaller. So what will the multiple thing I'm multiplying by will be less than 1.
You had a hat holder to say on it.
Huh?
You had a hat and like your gift shop.
My dad went to the Matt Myers statue and all I got was this dumb old hat.
We'll sell
Dad
Hawaiian
hat.
shirts.
It'll be a dad hat. And Riley's great-great-great-grandchildren will be buying it from Zoomies.
Yeah.
Okay, now listen to me. Here's what it means in math, okay? You take any measurement, and when I say any measurement, could I do this measurement on my body? Yes, and compare it to this on the statue. You with me? Okay? So you take a measurement, any measurement, from the model. So in my example, is that the statue or is it me? The model.
That's the statue.
That's the statue. And I divide it by the same measurement from the actual. So that would be Myers. Everybody got it? This answer, when you do this division, the answer is called the scale factor. Okay? If it is 0 to 1, I lie. If my scale factor, my SF, is greater than 0 but less than 1, I have a reduction. The model is smaller than the original. The keychains, the little statues. If my scale factor is greater than 1, I have an enlargement. Is everybody okay with that? Okay? All right. Now turn the page over and let's actually use this. Okay? There's a drawing of a pin. The actual length of the pin is 13 millimeters. Find the scale factor for this diagram. How do we find scale factor? It's model divided by actual. So, do I know the actual length of this pin?
Yeah.
What is it? 13. Right? Do I know the length of the model?
No.
How do I find it?
No clue.
This is not a trick question. How would you find the length of this model?
Measure it.
Measure it!
Oh.
Okay? So, I'm going to help you out because I don't want to give out the rulers unless anybody has one on them and wants to measure this quickly for us.
Yeah, our Steve, you the man. Come on, man. Whip that thing out.
3.6 centimeters. Now here's the problem. What's the actual length of the pin? 13 millimeters. Is that cool? No, because of this. The units must be the same. So how do I make centimeters to millimeters? Times 100?
Just keep up.
Centi to milli is one step, right? So it's just times 10. So it's 36 over 13, right? Everybody got it? Then I would do that math. What is it? What's 36 divided by 13? 2.77, because it's 2.76 something, right? 2.769? So it's 2.77. Everyone cool?
When you divide it, you have to get rid of the decimal?
Just wait a sec, Craig. I'll come back to that.
Wait, Craig.
So this is my scale factor. That means every measurement on the actual pin multiplies by this to get the model. Okay? So what does that mean for us? That means my actual pin, which was 13 millimeters, multiplies by my scale factor, which in this case was 2.77, and that gets me my model, which in this case was 36 millimeters, which you can see quite plainly is an enlargement. Now you knew it was going to be an enlargement as soon as you did this, right? Because that's bigger than 1. Everybody got it? Okay, let's see if you can do this. There's an ant. Doesn't matter. How big is the actual ant? 6 millimeters. The actual length is 6 millimeters. Now, measure the length of the ant in the diagram. You guys don't have your rulers. I'm going to help you out. It's 3 centimeters. What is wrong with this? It's centimeters. I better make it millimeters. So what is it? 30 millimeters. Now, scale diagram, model, over ant, actual. What's the distance or the measurement on the model? 30. What's the measurement of the actual? 6. What's 30 divided by 6? 5. So what is the scale factor? 5. What does that mean for us? Any measurement on the actual ant multiplies by what? By what for the model? What? By 10? The scale factor is 5. So it always multiplies by 5. What if I'm going the other way?
Divide.
You would divide. So if I measured this antenna on the drawing, what would I do to tell me the antenna length of the actual ant? Divide by 5. Everybody got it? It works both ways. And it's got a lot of real life uses. Okay, I'm going to show you one in a second. This is a little hard to see because it doesn't photocopy well. So I'm going to draw them on here. All right. Now, what is the length in the diagram? 9? Did you count it? 1, 2, 3, 4, 5, 6, 7, 8, 9. Perfect. 9. What is the length in the original? 3. So, the model is this one. 9. The original is 3. What's 9 divided by 3? 3. So the scale factor is 3. Does everybody understand that? That means any measurement from the original multiplied by 3 will give me the model. Let's check. What's the width? 2. So 2, my width, equals 2 on the original, times my scale factor of 3 gets me what width on the big one? 1, 2, 3, 4, 5, 6. Oh my goodness, it works. Is everybody with me? Okay? That was Arsh being those guys from Sesame Street. Yep. You know those aliens that come down? You guys don't know the yep aliens? Well, you know YouTube's coming out in a minute. Let's move it along. Now, remember, this applies to everything. In math class, we're using stupid little shapes, right? How does it apply in real life? I already gave you the examples, blueprints, things like that, yeah? All right, so here we go. This cylinder is to be enlarged by this scale factor. Barf! Do we like that scale factor?
No.
No,
Why?
ugly.
It's a
It's
fraction.
a fraction. What can we do to every fraction to make it something we like? Divide it. Let's do the math. First of all, our scale factor is 5/2. What would we do with that to make it something pretty?
Divide 5 by 2.
Which is 2.5. But there's another piece of information in our scale factor, isn't there? 5 is on what? The model or the actual? The model. And 2 is on the actual, correct? Because it's a fraction, it's already set up for us. Now I want to find the dimensions of the enlargement. So remember, dimensions are always the actual times the scale factor will get me the model. Yes? So this is what I'm starting with, correct? So what is the diameter that I am starting with? 2. What is my scale factor? Or 2.5. They're both the same thing, right, Bryn? 2 times my scale factor. So what is the diameter in my enlargement? Five. Then I do the height, because that's the only other dimension I need. What was my height in the original? 5 times, what was my scale factor? 2.5. I'll help you out, because okay, 12.5 is my new height. Has everybody got it? Now I told you I was going to show you a real life use for this, okay? Here is one of them. No. I'm showing you a real life use for it. Ah, damn it. I always choose this one.
What is that? World's biggest wave?
Yep.
What is that?
What? So that doesn't look like much, yeah? Now watch. They will zoom out because they're filming this from a helicopter. Keep watching. Yeah, okay.
That's not real.
Yeah, okay. Keep watching. Keep watching. Keep watching. Oh no! Look out! But wait! Wait! Oh! He's still on his feet! Hold up. He's still there. He makes it through. Now he's dead. No, he doesn't die. He just has bailed. Okay, now, the question becomes,
They should have zoomed out more like the whole way.
the question becomes, how was that measured? How did they know how tall that wave was? Because they know. Was there a guy swimming in that wave with a tape measure?
Yeah.
No. So how did they do it? No. What?
They use a surfer.
Yes. How?
They timed him by how
They
many
got
times?
his height.
They got his height, which they know. It's a model, isn't it? They stop the picture. They know how tall the dude is in real life. They know how tall the dude is in the photo. Find the scale factor, measure the wave in the photo, multiply by the scale factor, and you've got it. How do we use it in real life? Not surfing, because I care about surfing. It's how they do things like crime scene investigations from a car accident. Right? Yeah, they use Photoshop.
Like Kim Kardashian, right?
They measure the skid marks on the ground in the picture. They measure the skid marks in real life. They use that to figure out the speed of the car. Things like that. Okay?
How do they figure out this?
How do they figure out the speed?
Huh?
How do they figure out
How
this?
do you figure out the speed?
That, then you need physics
Oh.
as well. But you're still using scale factors.
They can look at it like.
They're like,
Yeah, just.
No. It's not like Horatio on CSI Miami.
He's just like.
I remember there was one. It was on CSI. With the
All CSIs are idiotic. They're all stupid. Every single one. Stop it. I don't even want to talk about it. They're all stupid. Yes, it's funny because it's stupid.
No, it's not stupid.
Fine, go.
They had a picture of a license plate and they enhanced on.
Oh yeah, that's my favorite. Enhanced. Enhanced.
On a
Doesn't work
screw,
that way.
On a screw. And then
Yeah.
plug the screw and
Yeah.
it's all like that.
Doesn't work that way. The number one thing that CSI shows have done for the world is make all of you think that being a CSI is super sexy awesome.
It is.
When you go to work as a CSI, you're not going to find that woman from CSI running around in her tank top. That's not the way people dress at work.
I don't know that.
Yes, I do. What with being a worker. Anyways, so here we go. I have this photo. Is that an actual or a model? It's tricky.
Well, no, it's that.
It's the actual thing, isn't it? It's a model of reality, but it becomes an actual thing because I'm going to be enlarging it. Understand? Another way to look at actual is the original thing. So we're going to take this photo, which is a model itself, and then we're going to enlarge it or shrink it, right? For example, that picture of that building from Belgium right there. Is the building that small? No.
I can't even.
So that picture is a reduction of the building, yes? But if I like that picture and I want it bigger, then I'm going to be enlarging that. So that, even though it's a model, has become an original thing that I'm going to enlarge. Understand? Okay. So, what is the length of the original photo?
10 by 15.
10. Length? No, it's not 10. What's the length? 15. Scale factor is 4. So every measurement multiplies by the scale factor, right?
Yeah.
So 4 times 15. So the new picture is 60 centimeters long. What's the width? By? So it's 40. So the new picture is 60 by 40. An enlargement of the original picture, but still a reduction of real life. Yeah? Okay. What about this one? Do we like that scale factor? No, it stinks. So what do? 13 divided by 4 to get 3.25, yeah?
Yes.
So, what was my length of the original photo? 15. What do I multiply by now? No. 3.25 to get what? You're going to use your calculator.
45 something.
Yeah, it's 45.75.
45.75.
Oh,
No,
48.75.
48.75.
Stupid, Perry. I told you. I wasn't sure.
10 by 3.25 is going to be 32.5. So the enlargement would be 48.75 by 32.5. Everybody cool? So, 1, get your scale factors as decimals. 2, recognize if your scale factor is bigger than 1, it's an enlargement, smaller than 1, it's a reduction. 3, make sure your measurements are in the same units. Everybody good? Really good? Okay, let's see if you're really good. Because we have only done enlargements. Everybody screws up when we go to reductions. Okay? If an enlargement is expanding all the dimensions, what must the reduction be? Reductions
Even smaller.
reduce all the measurements. So our scale factors are always 0 to 1. 0 to 1 as a decimal. Okay? As a fraction, they're 0 to 1 over 1. So, 0.75, is that going to be a reduction?
Yeah.
Yes.
Okay, yeah.
2/5, is that going to be a reduction?
Yeah.
Yes, because 2/5 is less than 1. Okay? Can you have a negative scale factor?
Yeah.
No.
No.
Why?
You can't make nothing.
I can't disappear. If you're going to use a scale factor of negative, that would make my height of positive 5 foot 8 inches disappear
I can make you
to be a negative number, which doesn't exist. Yeah, I skish your head. I make you disappear too.
You can go in the ground.
So, scale factor for this reduction.
Put him in a cup.
What if this wasn't written here? How would you know which was the actual and which was the model?
The bigger one?
The bigger one's the original because it tells you it's a reduction, yes? So, do you think the rules change? Of course not. We have our actual. Actual and model. So what is the best measurement to use to figure out the scale reduction? Can you use any measurement? Yeah, what was the easiest one to use? What's the easiest measurement from a circle to get? No, that's a type of measurement. What is a measurement from this circle that you can get just by looking at it?
Oakland, Duncan.
That's so cute that you two are playing with your tongues.
Can you do this? That's really cool.
No, you won't. You're a liar, which is almost as bad as the fact that you're playing with Riley's tongue with him.
How's he playing with my tongue?
Oh my
Yes, you were. I watched you.
How's he playing with my tongue?
Well, you guys are playing with each other by using your tongues.
So he's not playing with
That's
my
weird.
tongue. He's not playing with my tongue.
Okay.
I'll play with my tongue and he'll play with his tongue.
Yeah.
Okay.
We're playing with our tongue.
Okay. You can say it that way. That's fine.
That's how it
The rest of us see two gentlemen staring at each other going, but that's okay. Whatever paddles your canoe, boys. It's not me. Whatever gets you through the night. So I'll ask again.
That's not
What
that-
is it's not funny because it's not happening to you. If I was, or it was happening to you. If I made that joke about the BA and Dylan, you guys would, but because I'm aiming it at you, like, that's not funny. Whatever. Because you two are so original, right? I've never come across students like you guys before, ever. What is the easy measurement to get from this circle?
You're early, dude.
I'm the new breed.
Mm-hmm.
Playing with
I'll help you out. Is that a measurement on the circle? What is it? Diameter. And it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, yes? Is that the model or the actual?
actual model.
So where does it go?
Bottom.
What is it on the model? Because I got to take the same measurement. 4. Is that the scale factor?
Yeah.
Is it allowed to be in a fraction? It's allowed. Is it less than 1? So it makes a reduction, so we're okay. What's the other way I could write that? Which would be 0.4. Cool? All right. So, here we go. Measure the length of the original line segment. Again, I want to save time. On my sheet, it is 3.8. Measure the length of the reduction. It is 2. How do I draw it?
3.8 over 2.
No,
2 over 3.
2.8 over 3 to get the scale factor of,
Oh, yeah, it's 3.8.
Mr. Myers.
oh, sorry,
Yeah, Mr.
You
Myers.
remember not us scribbling with the tongues when you were telling us about the tongue story earlier?
Yeah,
were we doing work?
I'm not sure.
Exactly.
Yeah, we were.
No, we were
Doing
not.
our reviews.
No, we were not.
Yeah, we were. I remember.
You remember poorly.
He remembers poorly too.
You were no. Your review had been assigned to you, but none of you were doing it.
I did.
There's a significant difference,
I didn't remember.
okay? Someday, hopefully in the next 3, you will understand that I win the arguments
Yeah.
because I'm smarter than you,
That is true.
okay? You think you're smarter than me because you're teenagers. I get that. And when I'm 80 and I've turned really senile and you guys are, let's see, in 80, I'll be 40 years, and you guys are 53, I'll still be smarter than you. Okay? So learn it. Now here. What?
Can we go back up? Is it the original length is at the bottom?
Yeah, the original was 3.8, should have been down here, 2 over 3.8, which is actually what I did on my calculator if you look, and got 0.9. Now, real life. 165 by 105. How big's the reduction? What do I got to do with those two numbers? What do I do with every measurement to create a scale diagram?
Divide.
No.
Multiply.
Multiply by what?
By 1 over 5. No, by 5.
By 10. But divide by 10.
By 5.
1.
4.
I love it when the people that don't pay any attention just start yelling random numbers.
Hey, I said the right
No one else
number.
is saying anything.
I know, because they don't know.
But at least we're trying.
Answer is always
At least we're trying.
measurement times scale factor. I know I did say that a long time ago, and we've only done 1, 2, 3, 4, 5,
Wait,
6,
he said
7.
1 over 5.
Yeah,
8.
1 over 5.
Oh, did he?
He did.
Okay, so multiply that by 1 over 5. Go.
Okay.
So what's the answer?
Huh. I think about it.
Keep thinking.
Take me.
I know. I've already got the answer.
I'm going to get the answer right now.
What is
Times
it?
105.
No.
1,000.
No.
Solar reduction.
14.5.
No.
We don't know the dimensions of the.
Yes, you do. You're finding the dimensions of the
We
reduction.
don't know it yet.
Because you have to do this calculation, Perry.
Well, we don't know what the like.
You do know how to do this calculation. I've already showed you. What did you do the last time you had a fractional?
I am.
Oh, made it into a decimal.
I did it. I got 33 over 21.
It is 33.
I know how to do this. I've been paying attention the whole time.
I was right. That's what it said.
No, it isn't. But that is beside the point.
You divide.
What you did was you went 165 times 0.2.
Because 1.
Okay, so I did.
And 105 times 0.2. The other thing you could have done, Craig, was this. You could also have done this. 165 times 1 over 5. 165 times 1 is 165 divided by 5, which would get you the same answer. Both of them are acceptable. You guys need to work on those pages. No, it's not, because it is, once again, just scale factor. It's multiplying one number, and I give you a calculator. And obviously, based on the last test scores, you guys aren't practicing enough on current math, are you?
Can I go to the washroom real quick?
Yes.
Look at my bling, bro.